Okay, so we've previously seen that when we have a plane running through a cone and it's parallel to the base of the cone, that it creates a circle. Also, if we tilt that plane so that it goes right through the top of the cone, we're going to get a parabola. Well, now we have the situation where it's not quite completely through the plane. It's not completely through the base of the cone, and it's not completely parallel to the base of the cone. So we have it sort of slanted a little bit, making this ellipse. So an ellipse is just a mathematical name for an oval. So here we have an ellipse. We define an ellipse as a set of all points in the plane whose sum distances from two distinct fixed points, foci. So here we have focus. The plural of focus is foci or foci. It doesn't matter. Dialects, I guess. But notice that these two distances, they're not the same distance. But the sum is. So no matter where we go, no matter which point we choose, these two distances added together will be the same. So just a couple of key vocabulary pieces here. So we have the center, as per usual. We have the two vertices, and the two vertices are connected along the major axis. And then we have the minor axis, which connects these two up here. So the major axis is just the longer one, the minor axis is the shorter one. So if you had a circle, those two would be the same distance. However, with an ellipse, there's going to be a larger axis, and we call that larger axis the major axis. So here are the equations. They're a little bit more complex than some of the other equations we've seen. Now the foci lie on the major axis, and they're going to be c units apart from the center. So c is going to be equal to a squared minus b squared. Those are values of a's. Well, we know that the lengths of the major and minor axes are going to be 2a and 2b. So this distance here is going to be a, and this distance here is going to be a. So when we add them together, we get the total distance of the major axis, which is 2a. Now the minor axis is going to be a distance of b and a distance of b. So we add those together to get 2b. And so, of course, a is going to be a larger value. Now here is when the major axis is horizontal. So just like in this picture, the major axis is horizontal. Here is the equation. Notice it looks very, very similar to the circle, right? X minus a squared, or x minus h squared, y minus k squared. But now we are dividing by a squared and b squared. We are dividing by the length squared of the axes. And same over here. Now notice we write x, y, x, y. The only difference is that the a and the b switch. So if you think that the b is the minor axis and the a is the major axis, right? When the major axis is horizontal, it's paired up with x. When the major axis is vertical, like this, it's paired up with y. And that's just a nice little way to know the formula there. Okay, so let's look at some pictures here, just again showing everything that we've just seen. All right, so we want to find the standard form of the equation of the ellipse having foci at 0, 1 and 4, 1, and a major axis of 6. Well, if we just kind of think about graphically what this is going to look like, we get 0, 1, 1, 2, 3, 4, 4, 1. We can see that these are foci. Foci, we know, are on the major axis. So then this is a horizontal. So we know we're going to have x minus h squared over a squared. plus y minus k squared over b squared equals 1. Now the major axis has a length of 6, so that means that 2a is equal to 6, so a is equal to 3. Fantastic. And we know the foci lie c units from the center. So center is going to be halfway between these two. So that's right there. So this is 0, 1. This is 4, 1. Halfway between, we take the average. If you want, you can use the midpoint formula. And we're going to get 2, 1. So the distance here, c is equal to 2. Well, c squared is equal to a squared minus b squared. So we got to figure out what b is. So we're going to have 4 is equal to 9 minus b squared. So b squared is equal to 5. So then we just plug everything into the formula. We already found out that the center there is 2, 1. So this is going to be x minus 2. Actually, let's fix this up. So we're going to have x minus 2 squared. A is the going to be 3. So that's a squared is 9 plus y minus k is y minus 1 squared over b squared. B squared we said was 5, and this equals 1. And there is our formula. So it's a couple different steps there. It takes a little bit of detective work to find all the different pieces. So make sure you're familiar with the different pieces, what you need to find. There's a lot of different variables here to track down. Okay, now we want to sketch the graph of this ellipse. Well, if you look, this kind of looks a little bit different from how we've seen before. We're used to having fractions and denominators. Here we don't. But if you notice, both of these equations are equal to 1. So this one is equal to 36. So the very first thing we could do is we could just divide everything by 36. And so we get x squared over 9 plus y squared over 36 equals 1. So now, sketch the graph given by this. And so now we can kind of see what these values are going to be. Well, we say that a is equal to 3, b is equal to 6, because this would be a squared and b squared. We have a nice horizontal. X minus h, y minus k. The center is going to be at 0, 0. Major axis is going to be 3, so 1, 2, 3. 1, 2, 3. And the minor axis. Oh, sorry. Right, A and B. Which one is A? Which one's B? I got into the habit of doing the other one. Look, A is always going to be larger than B, correct? So that means that A is equal to 6 and B is equal to 3. This is A and this is B, meaning we have ourselves a vertical parabola. The center's still at 0, 0. And so the major axis, we're going to go up 6. So 1, 2, 3, 4, 5, 6. And down 6. 1, 2, 3, 4, 5, 6. We're going to go to the right. 1, 2, 3. And to the left. 1, 2, 3. And there is our parabola. It's a beautiful piece of art. So that's our ellipse. So the important thing is, it's not given if this is a vertical or horizontal major axis, so we need to figure that out. And the way that we figure that out is by looking at which value is bigger. That's going to be our a squared value. All right, next up we want to find the center, vertices, foci of this ellipse. So if you remember from before when we had our circle, we needed to do a difference of two squares, completing the square for both of these. So I'm going to combine all my terms together. So I'm going to turn this into 4x squared minus 8x plus y squared plus 4y equals 8. I just added that 8 onto the other side. And now what I can do is I can complete the square. So this is going to be 4 times x squared minus 2x plus something plus this is going to be y squared plus 4y plus something equals 8. So here I take this middle term, divide by 2, and square it. So I'm going to get 1. So I have to add 1 over here. Here I'm going to take this 4, divide by 2, and square it to get 4. So I'm going to add a 4 over there. So I get x minus 1 squared plus y plus 2 squared. And this is all going to equal 13. I think I did that math right. So 4 divided by 2 is 2. 2 squared is 4. Yeah, so shouldn't have any coefficients there, though. So I guess this is just a little bit trickier of a problem than I had thought. But no difference, no difference. So here, we want to make sure that we have to have this equal to 1. So we're going to divide everything by 13. 8. So 4x squared minus 8x. Right, factor out the 4, get 2x plus 1. Yeah, that's 13. Okay, so we're going to divide everything by 13. So we get 4 times x minus 1 squared over 13 plus y plus 2 squared over 13 equals 1. Now the issue here, and this is kind of why I was second guessing myself, was that we need to take this numerator. We can't have any coefficient in the numerator. So what we need to do is we need to rewrite this so that it's just x minus 1 in the numerator. Well, we're going to have a fraction in a fraction here. So this is actually going to have to be 13 over 4 because just for a second, if you think about that, this is really x minus 1 squared divided by 13 over 4. But when we divide by a fraction, we're going to have to multiply by the reciprocal. So 4 over 13. And so that's how we get this value here. So it's just rewriting it. I know it looks not great, but it's okay. All right. And so that's our equation. So now we have everything we need. We know that A is going to be the larger value. So here we can see that A is equal to 13. B is equal to, or A squared is equal to 13. B is equal to, or B squared is equal to 13 over 4. And we know that because 13 is a lot bigger than itself divided by 4. The center is the easy one, so that's h comma k, so it's 1 comma negative 2. The vertices, we're going to add a to both sides along the major axis. So from this, because A is larger, we can see that this has a horizontal major axis. And so going back here, oh sorry, not horizontal, that's a vertical. That is a vertical. Okay, so vertical major axis. And so what we need to do is we need to figure out where these vertices are going to be. So we're just going to have to add A to the y value and subtract A. So the vertices along the major axis are going to be 1 and comma negative 2, and this is going to be plus the square root of 13. And then we're also going to have 1 comma negative 2 minus the square root of 13, because we have to add and subtract A. Similarly, we're going to do that to B. So along the x-axis, it's going to be 1 plus the square root of 13 over 2, comma negative 2. And that 1 minus the square root of 13 over 2, comma negative 2. How did I get this 2? Well, the square root of 4 is 2. We leave the square root of 13 as the square root of 13 because we can't take the square root of an integer, or of a non-square, perfect square, and get an integer value. So we just leave it like that. So there are the vertices. Now to find the foci are c units away from the center. So c squared is equal to a squared minus b squared. So that means that c squared is equal to a squared minus b squared. So c squared is equal to, oh boy, if I want that common denominator, I'm going to have to multiply this by 4. So that's going to be 52. That's 13 over 4. So c squared is equal to, this is going to be 40. So 39 over 4. The deeper I get into this, the more I feel like I made a mistake. So if you did make a mistake, please let me, or if I did make a mistake, please let me know here. I'm clearly not catching it right now, but I'm sure I'll probably figure it out later. Hopefully. Right. So what we want to do next, I guess I could have divided, it doesn't matter. All right, so the foci are going to be on the major axis. So where's that good picture? Right, so the foci are along the major axis, and they're c distances away. So that means that we're going to have to add c to the x values. So to the y values, because this is vertical. Oh, I'm just making all sorts of mistakes here. So the foci, we're going to have this at 1 comma negative 2 plus the square root of 39 over 2, and then 1 comma negative 2 minus the square root of 39 over 2. So there's a lot going on for that problem. And so hopefully everything was done right. Yeah, I mean, I'm not seeing my mistake, but yeah, I'm sure it's there. Otherwise, these numbers are just ugly, but everything is fine. All right, so maybe because that's the end of the video, maybe that was supposed to be a little bit of a challenge, get our practice with fractions. So make sure that you are getting some practice with this, looking at the numbers, and checking all your work, as I'm probably going to do after I close out this video.